Solving trigonometric equations, worksheet 3 solutions. Solve for x in the interval 0 to 360 degrees or 0 to 2 pi, right? Those of you who are working in radians can do 0 to 2 pi, and those who are not will do it in degrees, right? Now, here is a very interesting question. Cosecant x equals to square root of 3 minus cotangent x. Well, this is probably the only one in my worksheet which has the secondary trigonometric ratios, right? And it is a very important problem which I've seen in many test papers. So go through it very carefully. So first thing what we should do is write them in sine and cosine. So cosecant x is 1 over sine x, correct? So we write this as 1 over sine x equals to square root of 3 minus cos x over sine x. Now, as soon as you write this, you know sine x is now in the denominator, so we have a restriction here, right? If you look into the sine wave, then within a period of 0 to 360 degrees, it is 0 3 times, right? So that is your sine wave, and you'll find that it is 0 for x equals to 0, x equals to 180 degrees, and x equals to 360 degrees, right? So that is your sine x. So denominator cannot be 0. So first thing you should note is restrictions. So you should write down your restrictions here. In your domain of 0 to 360 degrees, the restriction is that x is not equal to 0 or 180 degrees or 360 degrees, right? Or 360 degrees, correct? So that is kind of most important thing to do at this stage. Now let's move on and try to find the solution. Solve this equation. We can multiply both left side and right side by sine x, and then we get 1 equals to square root of 3 sine x minus cosine x, correct? Now we can bring the terms together, and then we get what? We get 1 plus cosine x, we're bringing it here, equals to square root of 3 sine x, correct? Now we can square both sides to find a quadratic equation in one variable, right? If we square, we get sine square x, which could be written as 1 minus cos square x, correct? So that's what we'll do. We'll square both sides. So squaring both sides means incorporating errors. Can you tell me why? Why do we get errors when we square both sides in the equation? We are doing the same operation both sides. This is also a communication question asked many times, right? The reason is, let us say sine x, is negative in quadrant 3 and 4. So if we have negative here, and if you square it, it becomes positive, right? So, which is not true, correct? That is why we get some wrong results, right? And it becomes mandatory to test your results for the correct solution, right? Now we can expand this side and we can write sine square x in terms of cos square x. So when we expand here, we get 1 square plus 2 cos x plus cos square x equals to 3 times 1 minus cos square x, right? Now sine square x is 1 minus cos square x, so we get that. So let me take it on this side and then solve further. So what you see here is all terms in terms of cos square x or cos x or constant. So it's a quadratic equation in cos x, correct? So let's bring the terms together and solve it. So we will first rewrite this. So we get, let me rewrite it here, and then we'll take it on all the terms of one side, right? 1 plus 2 cos x plus cos square x plus 3 minus 3 cos square x, okay? So we'll bring these terms on the left side. So when I bring minus 3 cos square x to the left side, I get what? 4 cos square x. Let me write it here now. 4 cos square x, and we have 2 cos x here, plus 2 cos x As far as the numbers are concerned, 1 is here and we'll bring here minus 3. So we get minus 2 equals to 0, right? So that's the quadratic equation which we get at this stage. So from here what we can do is we can take 2 common and then we'll further factor. So when I take 2 common, I get 2 cos square x plus cos x minus 1 equals to 0. And now we can factor it, trying to find product and sum. So we are looking for two numbers whose product is 2 times minus 1. So we're looking for two numbers whose product is minus 2. And their sum should be plus 1. So the two numbers are 2 times 1, right? So we'll have 2 plus and minus 1. So we can write this as 2 cos square x plus 2 cos x minus cos x. So cos x can be written as 2 cos x minus cos x, and here we have 1, right? Equals to 0. Now this can be factored. You can take 2 common here. So we get 2 cos x, and you're left with cos x here minus or plus 1 here, and then you take minus common and you get cos x plus 1 there also, correct? Bracket close. So now we have the factored form, and to avoid the confusion, let me do it like this, use a different ink. So we get 2, so all this let's write equal to, right? So we get, this implies this, right? So we went from here to here, and now what we have here is we'll take cos x plus 1 common, right? So we have cos x plus 1, and we're left with 2 cos x minus 1. Minus 1 equals to 0, right? That gives us possibility of couple of answers, right? This bracket is not here. It is 2 cos x minus 1. So the possible solutions for us are, this could be 0, right? That means cos x could be equals to minus 1, and this could be 0. That means cos x equals to half, right? That will give me this 0, right? Now cos x equals to minus 1, that means we have a possible solution. Let me just push this sheet a bit further so that things are clear to you. Now cos x is minus 1 at where? So it is, let me sketch it here on the side, cos x, right? So cos x is kind of like this, right? So it's minus 1 at this point, which is 180 degrees. Correct? So one answer is 180 degrees. So this is 180 degrees is our solution here. That is the value of x. And how about half? To find where the cos x is half, we can use the special triangle, correct? So the special triangle which we can use is 1, 2, square root 3, and that angle is 60 degrees for us, correct? Now since cos is positive in 2 quadrants, right? So we have 60 degrees here and 60 degrees here. So the two answers are for this x equals to 60 degrees and x equals to 360 minus 60, right? Which is 300 degrees. So these are 3 possible answers for us. Now the thing is that you have to check which ones are valid answers for us. Clearly 180 degrees is not a valid answer, right? Because that makes this equation undefined, correct? We cannot have 180 degrees as one solution, so that is not possible. So this is not a part of solution, correct? Now we can check for 60 degrees and 300 degrees. Remember, we squared both sides. That means we incorporated error. We made some negative quantities positive, right? Therefore, it's a good idea at this stage to plug in these values and check for the answer. So if you check it, so cos 60 degrees, right? So when you check for cos 60 degrees, let's put cosecant 60 degrees. That means we're looking into this triangle, right? In this triangle, what is cosecant 60 degrees? Cosecant is 1 over sine. That means 2 over square root 3, right? So we get here, so let me write down the values and test right there. So for 60 degrees, we get cosecant is 1 over sine. That means 2 over square root 3, right? 2 over square root 3. This we are checking for 60 degrees, right? Which is equals to, on the right side, we have square root 3 here minus cotangent. And what is cotangent for 60? Well, tan is this, cotangent is 1 over square root 3. It's 1 over square root 3, right? Correct. So if we solve for this, we get square root 3 times square root 3 is 3, and 3 minus 1 is 2. So that is correct. So this is correct solution, right? Now, let us plug in 300 degrees, which is effectively, in this quadrant, minus 60, right? Now here, cot and cosecant both are negative, right? So on the left side, what you get will be, because cosecant is negative, will be negative, right? And here, because cot is negative, that will make this as positive, right? So when you add them up, now this time you get square root 3 times 3 is 3, and 3 plus 1 is 4. So you don't really get minus 2 over square root 3, you get 4 over square root 3. So that is not a valid solution, correct? So therefore, in this particular case, the only solution is, that means our answer for this is 60 degrees, right? Do you see that? That is the only valid answer for us, correct? So it is kind of important and necessary to check your result before writing the real solution, okay? Thank you.